Now for these problems, you want to make sure that you are factoring and it's equal to 0. So equaling to 0 means that you're gonna have to separate them as well. The first step you want to do is find the greatest common factor. In this case, it's 1. So then you can go straight to the x in the box. So negative 40 and then 18. In this case, 20 and negative 2 are going to be your magic numbers. Those magic numbers, you put an x next to. And then first term, first box, last term, last box. And now on the calculator, you're just going to do GCD 5 comma negative 2. It's going to get you a 1. And then you have to know that it's an x. Greatest common factor between 20 and negative 8 is a positive 4. It's positive because our leading coefficient's positive. Then you go upright, 5x squared and 20x. The greatest common factor is 5x. And then negative 2. It is a negative because this is negative, so this has to be negative. Now once you get to that point, you put it in parentheses. Now it doesn't matter which parenthesis you put first, and then you separate them. Sorry, that should be a plus sign. I was getting ahead of myself. And then it's just a 1-step or a 2-step. Add 2 on both sides. Now you can write them as set notation, or you could write them as 2 ordered pairs like you did in problem number 3 of the study guide. On the unit test, you can put this whole equation in, not the x, not the equal 0 part, and then menu 6-1 and do that twice to see if you're right. Now number 10 is more complicated for 2 reasons. First reason is it's not equal to 0, so to undo a positive 29, you minus 29. And then from there, you got to be very careful. In the answer key, I actually made this mistake. You have to do step 1. You have to find the greatest common factor. If you don't, your box will not make sense in the end. Now from here, you can do the x and the box. So 1 times negative 9 is negative 9, and then 0. What are our 2 positives? I'm sorry, what are our 2 magic numbers? 3 times negative 3 gets you back to negative 9. Add them together, it gets you to 0. So that is what our x's are here. And then first term, last term go in the box. And then you find the greatest common factor from there. And I actually made a mistake. This right here is not your first term. Sorry. You want to make sure that you do your new problem. Your new problem's first term is 1x squared and then minus 9. So I did part of it right. And then greatest common factor is 1x, and then it's 3, and this is 1x, and this is negative 3. Once again, it doesn't matter the order you put in the parentheses. and you separate it. Now, you don't have to show this one step. If you just see the opposite, that's fine with us. Now, quadratic formula, you got to be very careful. Once again, just like the first problems, it needs to be equal to 0. If not, you're going to have to make it equal to 0. Label your A, your B, and your C, and plug them in. So x equals the opposite of b plus minus square root b squared minus 4 times 6 times negative 88 all over 2 times 6. Now, I really recommend you do the discriminant first. The discriminant goes into the calculator without the square root. So 17 squared minus 4 times your A value, which is 6, times your C value, which is 2,401. And then you simplify. Opposite of 17 is negative 17 plus the square root of that big number that you just got. 2 times 6 is 12. And then you do the same thing, just make it a minus. And then you have two easy numbers. Remember this plus minus, that's where I got the plus from, and that's where I got the minus from. On this calculator, hit Control Divide, so you make sure that you set it up correctly. I'm just going to leave it as a fraction. Either way will be fine on Wednesday. Hit the up arrow twice to highlight, and all you're changing is the minus. Sorry, I did that too much. So then you get negative 11 over 2. Now, you're going to do the same thing for number 12, but it's not equal to 0, so you have to minus 50 on both sides. And then just fill in the missing pieces. The negative 50 doesn't combine, so that will actually become our C value. Now, I'm not going to do number 12 because this setup is exactly like number 11. It's really just plug and chug.